This is Dr. G. Vikas Paul. In this session, we'll discuss about Castigliano's first theorem and second theorem. Castigliano's first theorem states that for any member subjected to system of forces, the load at any point is equal to partial derivative of the strain energy with respect to the deflection. So, for any member subjected to system of forces, suppose if we consider a simply supported beam subjected to system of forces P1, P2, P3, P and Pn, the load at any point is equal to the means the load at any point is equal to means P is equal to partial derivative of the strain energy dou u with respect to deflection dou y. Okay, so P is equal to dou u by dou y. This is first theorem, Castigliano's first theorem. Whereas Castigliano's second theorem states that for any member subjected to, so this is member simply supported beam subjected to system of forces P1, P2, P3, P until Pn, the deflection at any point is equal to, suppose deflection at this point, the deflection is y1. So y1 is equal to partial derivative of strain energy with respect to that force dou u by dou p1. Okay, so y1 equal to dou u by dou p1, y2 equal to dou u by dou p2. So y equal to dou u by dou p is the Castigliano's second theorem. Just vice versa. So for the determinate structures, first we will see how to calculate the deflection using strain energy or using Castigliano's theorem, how to find the deflection. For the beam shown in the figure, this is a cantilever beam shown in the figure subjected to point load at free end. Okay. Find deflection at free end using Castigliano's theorem. So YB we need to find. Due to this load, there will be some deflection. YB we need to find using strain energy or Castigliano's theorem. First of all, this is a determinate structure. So degree of static independency, total number of reactions minus number of equilibrium equations. Total number of reactions 1, 2, 3 minus 3. Therefore, it is a determinate structure. Consider a section XX at a distance x, right. So here we need to find YB. So from Castigliano's theorem, second theorem, we have y equal to dou u by dou p. Yes. So from Castigliano's theorem, we have y equal to dou u by dou p. That means YB is equal to dou u by, what is P here? Load, force, W. So YB equal to dou u by dou W. Now we need to find u here first. Okay, we need to find u. What is the formula for u? Formula for u is integration mx square by 2a dx. Okay, this is strain energy formula for bending, due to bending. But here mx is unknown. First we need to find mx. For mx we need to consider a section. Okay, so consider the section xx at a distance x from b. Okay, this is b. Now at this section we need to find the moment. So mxx, forget this. Now mxx equal to w into x minus w into x. So mx equal to minus w into x. But we know that u equal to integration 0 to L mx square by 2a dx. So mx is nothing but minus wx. Simply substitute minus wx instead of mx. Okay, then we will get in this way. Now this is a constant, we can remove out, we can take it outside. Integration 0 to L x square dx. So x cube by 3. Okay, x cube by 3, 0 to L. So 0 to L. Okay, then integrating it, we will get substituting these limits, upper limit and lower limit, w square L cube by 6a we will get. This is the u. Okay, according to Castigliano's second theorem, y equal to dou u by dou p. So here we can substitute this one. So partial derivative we get. So here these are the constants. Only w square is there, 2w. So 2w L cube as it is. This is as it is, L cube by 6a. So w L cube by 3a is a YB. Next problem. This is also a determinate structure. Determine the strain energy in a simply supported beam. So this is a simply supported beam having a point load W at a distance A from the left support. So W is at a distance of A from left support A. Okay. Also find the deflection under the load. So under the load YC we need to find. Take the span of the beam as L. So we need to find strain energy and YC. So total number of reactions here is 2. So 2 is less than a total number of equilibrium equations 3, therefore it is a determinate structure. Now let us calculate the reactions first. How we can calculate the reactions RA RB? Applying sigma f sigma moment about b equal to 0, then we'll get this one RA here. Sigma moment about b equal to 0, RA into L minus W into B. Okay, so from here RA equal to WB by L. Then sigma Fy equal to 0, RA plus RB equal to W, and RB equal to W minus RA. RB equal to WL minus WB by L. So RB equal to W by L. RA equal to RB equal to WA by L. Now in this way we can find RA and RB. Okay. Now strain energy due to bending, U is equal to U1 plus U2. What is U1 and what is U2? Strain energy in between AC is U1. Strain energy between CB is U2. Okay, UAC plus UCB. Now what is the UAC? 1 by 2a into integration m square dx. So I'm taking here m1, this is m1 section here between AC as m1, section between CB as the moment between CB as moment at any section between CB as m2. Okay, m2. So the formula for u is 1 by 2a integration m square dx. So m1 square, here m2 square. But what are the limits here? It is 0 to a, it is 0 to b. Okay, see, now I'm taking the first one, u1 equal to uac equal to this portion. So I'm taking section from a, it is x. Okay, now I need to calculate m1. So m1 is equal to RA into X. What is RA? WB by L into X. So instead of M1, I will substitute WB by L into X. So WBX by L whole square. Okay. So integrating this, we will get, and substituting the limits, we will get this one. W square A cube B square by 6A L square. Next U2. U2 equal to UCB, that equal to here, this one. Now I need to find M2. So section I am taking between C and B at a distance of X from B. Okay, now if I calculate M2, it is WA by L into X, WA by L into X. So WA by L square X square. Now if I integrate this and apply the limits, I will get W square A square B cube by 6EI L square. So U equal to U1 plus U2. If I add this, I will get this one. Simplifying this, so A plus B means nothing but L. So L gets cancelled. U equal to W square A square B square by 6AI L. This is the strain energy. Now we need to find YC, deflection at C. How to find deflection at C? We know that strain energy equal to work done. So work done equal to average load into displacement. Average force means W by 2 for gradually applied force. It is W by 2 into displacement means YC. YC we need to find. So strain energy U equal to work done. So U already we have found equal to half W YC. YC we can find from this. We will get as W square B square by 3 EIL.